Hi class, so this is day 2 of or part 2 of our review video for Unit 8. Okay, so we are now finding the missing measure to the nearest tenth. All right, so that means we're going to use our trig functions, one of our trig functions. I'm going to just write SOHCAHTOA up here again. I introduced that to you in the first video. That means sine of theta is going to be opposite over hypotenuse, cosine of theta is adjacent over hypotenuse, and tangent of theta is opposite over adjacent. So we find our angle, and if you remember, we determine from the angle the sides. Are they opposite, adjacent, or hypotenuse, so that we know which of our trig functions to use. And we notice that we have across from 42 degrees is the opposite side, and this is the hypotenuse because it's across from the 90. So we have opposite and hypotenuse there, and that is going to be our sine function. And we always write sine and then the angle. Angle always follows the sine is equal to opposite over hypotenuse. And then we multiply by the hypotenuse, the denominator, in order to rid ourselves of the denominator and solve for x. So x is 14 times the sine of 42 degrees. We get our nice sweet little calculator over here. And first thing we're going to do is we're going to make sure our mode says degree. So we want to make sure we're in degrees because our question has been asked in degrees. We just type in what x is equal to. 14 times the sine of 42. And again, you don't even have to do the times sign. It's just 14 sine 42. 9.4 is the nearest tenth. So x is approximately 9.4. And we say approximately because we have to round. Okay. Next one, we have this angle here is 18 degrees. So that's our angle. 21 is directly opposite. So that's O. And then this is the hypotenuse because it's across from the 90-degree angle and it's x. So that's hypotenuse. Right? Opposite hypotenuse again is sine. So we figure out our function that way. It's sine, then we write in the angle. Sine 18 degrees is equal to opposite over hypotenuse, 21 over x. Now, this case, our x is on the denominator, and when you watch the video, recall that we just switch those two when x is on the denominator in order to solve for x, because at this point, we do need to solve for x so we know what to put into the calculator. When you switch those, you get x is equal to 21 over sine 18. Remember, the 21 stays stagnant because it's just nothing that switches, only the x and the sine switch. All right, so you're going to give yourself a little fraction by hitting the N over D button on your calculator or whatnot, and you're going to do 21 over sine 18. Now that sine 18 is just one number, and your calculator sees it as one number, but it's good to use your fraction button. So we get 67.95, rounds it up to 68.0. So x is approximately 60.0 is the nearest tenth. Okay, next one is an angle that we're looking for. When it's the angle, we use inverse. Remember our inverse function on our calculator, but we still figure out O's and H's and A's. So we have, this is an adjacent side. It runs right into the angle and it's a leg forming a 90. So it's going to be adjacent. This side right here is the hypotenuse, right? So we have A and H. So that over here is A and H cosine. And we write cosine inverse. So we're looking for an angle, and it is adjacent 19 over hypotenuse 23. Okay. So in the calculator, get our sweet little calculator over here, and we just do second cosine to get the cosine inverse. 19 divided 23. And that is 34.3. All right, so just type it in like that, 34.3, and that's the nearest tenth, but remember this is degrees because we're talking about angle measure. All right, the next one, we have our angle here. This side is opposite, just right opposite the angle, theta, and this side is opposite the 90, so it's hypotenuse. Opposite and hypotenuse is sine. Remember, you put in your inverse, and then you write the ratio of sides opposite to hypotenuse, which is 34 to 35. So we put in our calculator second sine in order to get the sine inverse. 34 divided 35 is 76.3. So it's going to be approximately, theta is approximately 76.3 degrees. All right, if the ratio of sides is such. Those are both angles. We have one more side measure to go. So this is your angle, theta here, 36. Directly opposite that is opposite, and x is adjacent because it runs right into the angle. They're both legs. Hypotenuse is out, so that's tangent, isn't it? Tangent of the angle, 76, is equal to the opposite, 21, over the adjacent x. Opposite over adjacent. Okay, so again, the hypotenuse, the denominator had the x on it, so we're just going to switch the two in order to solve for x. So x is equal to 21 over tangent 76. All right, so on your calculator, I'm going to just do 21 divide, show you how to do this in the calculator if you don't have the N over D button. If you put that tangent 76 in parentheses, you shouldn't have any problem. All right, when you divide. You just keep that whole thing in the denominator, which you shouldn't have to, but I would always, just to make sure that I get it right. So 5.2 is going to be your x, approximately 5.2. And then the last problem in this section is number 10, and it has an angle measure you're looking for. So again, it's inverse. So find your opposite and adjacents and hypotenuse. So across from the angle is 26, so it's opposite, and across from the 9 is 32, so it's hypotenuse. And that is sine, and we do sine inverse again because it's an angle we're looking for, and then the ratio, so opposite to hypotenuse, 26 over 32. So do second sine. Since it's an angle, anytime it's an angle, we do second, and then 26 divide 32, and that is meaning theta is approximately 54.3 degrees. All right, so that's that section. Very last section, a 24-foot ladder is placed against a building to reach a window on the second floor. The angle of depression from the top of the ladder to the bottom of the ladder is 62 degrees. Find the distance between the bottom of the ladder and the base of the building to the nearest tenth of a foot. So we have to draw, I would draw a picture. So you have a ladder, all right, and it's placed against the building. All right, to reach a window on the second floor, so we want to reach this window. It's a beautiful window, I know. The angle of depression from the top of the ladder to the bottom of the ladder is 62 degrees. So we know right here is 62 degrees, and it's the angle of depression. Now this angle and this angle are alternate interior angles, so they're going to be congruent. So putting the angle inside of the triangle allows us to, knowing that's the angle of depression, allows us to get the angle inside of the triangle. So find the distance between the bottom of the ladder and the base of the building to the nearest tenth of a foot. That's going to be x. And it says a 24-foot ladder. So we know that this ladder is 24 feet. So we have this side we're looking for, and we have this angle 62 degrees. So these two sides, according to this angle, the distance between the ladder and the building is x, and it's going to be the adjacent side because it's a leg, it's forming the right angle, and it's adjacent. And then the 24-foot ladder is the hypotenuse. So that's cosine. A and H is cosine. Cosine 62 degrees is adjacent over hypotenuse, x over 24. So x is equal to cosine 62 degrees. And, times 24, sorry, I have to times by 24. This is 21. Sorry, so x equals 24 times the cosine of 62. So if we type that in, 24 and then cosine 62, and we get 11.3. So that's approximately 11.3 feet from the building is where you want to place the ladder in order for it to reach to the window. Because you'd hate to get it above the window or below the window, because then it would be a little more work to get inside of the building if that's what your goal is. All right, well, maybe we just helped out a robber. I don't know. All right, there's your review. I hope you guys have a great day. And if you have any questions, don't hesitate to email me. Bye.